All right. Well, Stephen, we do have some breaking news that was literally just released. And I know that it's something you're definitely going to want to cover because today we saw the release of the ML Commons results of their training, HPC, and tiny benchmark suites. Every company in the machine learning space found something here that they want to talk about. Intel was showing Sapphire Rapids and Habana Gaudi 2. Nvidia was showing off the H100, and ARM's tiny inferencing results really shined. But even though they were happy about those things, not everyone was happy because some of the players are complaining that these tests are being gamed by a lot of the big players. Stephen, you've been following this very closely. What do you think about this?
Well, let's start with the final point first. So I know the fine folks over at ML Commons. David Cantor was a field day delegate, and I love what they're doing. I think that they have the best at heart. The problem is that anytime a benchmark becomes popular, anytime a benchmark becomes a differentiator for customers, it's going to be gamed. And frankly, I'm hearing from a lot of vendors, in fact, even the vendors that are doing well at these benchmarks, that there's a lot of gaming happening. That we're getting custom drivers, custom software tuned for the MLPerf benchmarks, and that's legal. Companies are able to deliver a hand-tuned benchmark, and in fact, that's one of the things that Nvidia is crowing about. That their A100 is 2.5 times faster than it originally was in some benchmarks because they did some work to make the thing work better. And actually, that's good, right? I mean, don't we want software tuning and so on to happen? And don't we want better software, better drivers, better optimizations, and so on in the stack? I guess the only time that you could really complain about that is if it no longer reflects real world use cases. And again, I know the people behind this, and I know that they want this to reflect real world use cases, and they're going to continue to push to make sure that we don't end up with a useless benchmark, that we end up with a benchmark that shows real world use. And in fact, that's one of the things I like the most about MLPerf is because it's not just one benchmark. It's not like, spec or something where it's like, here's the number, that's it. It's a whole bunch of benchmarks. It's a whole bunch of tests. And frankly, the coolest thing about these announcements is that if you look at the numbers, if you look at the graphs, it's like this product does really well in this application, in this use case with this framework. This one does really well in this completely different one. We've got training, we've got HPC, and we've got tiny. Now, if you just had kind of a number, like, I don't know, a Geekbench, I'm not picking on them, but it's just like, how fast is the thing? It's this fast. Well, that wouldn't be really as fun. Because frankly, the tiny ones would look really pathetic next to the HPC ones. But if you look at it in terms of what am I trying to do with ML and what hardware should I use for this particular application, it actually is incredibly valuable and incredibly illustrative. And it shows that there's actually a great market for all of these things.
So I think it's interesting you bring up the benchmark thing because if I went to you and I said, I want you to buy the best car, the first thing you're going to ask is, well, what do you want it to do? Do you want it to go really fast? Do you want it to be very reliable? Do you want it to be able to haul a couch? Like there's different classifications of how you want a car to perform. It's the old Einstein quote, if you judge a goldfish's ability to scale a tree, you'll think it's an idiot for the rest of its life. But I feel like that's what a lot of the benchmarks do because the people who are making the purchasing decisions just want to see a big number. And so, yeah, gaming the system. I mean, Volkswagen had software in their cars that detected when it was being on a bench suite and it reduced performance to get under emissions guidelines. Samsung was specifically looking for certain benchmarking suites running on the phone so that it could ramp up the cores to make them run super, super fast, even though the core would never run that fast in reality. As long as there's a score to beat, people are going to beat it. I mean, I can think of, firewall throughput tests, and they have to very carefully disclose the fact that those were 64-byte packets, which is something nobody would ever send in reality. But boy, it made that throughput number look really big. And so I think that ML Commons is doing it the right way. They're saying, don't pick based on the score, pick based on the application. Do you need it to do this? Well, then here's the benchmark that you want to use, and it shows this. But if that changes, then you need to use this one over here. Don't just assume that the thing that was really, really good at this one thing is going to be really, really good at everything. And we have to get past that mentality. And unfortunately, it means that we have to do a lot of research. And that means we have to understand what we're trying to do and not just buy the biggest or the shiniest or, unfortunately, in some cases, the cheapest. And so the work that they're doing and the fact that they're putting out these results regularly helps people kind of chart that course. I mean, think back to the last time that Intel, or not Intel, but Apple released a brand new device, whether it was an iPhone or a MacBook or an iPad. I can promise you it's going to be about 15 to 20% faster than the last one. And it's probably going to have about the same battery life for everything. So, I mean, that's kind of where we're at with things.
So let's dive in a little bit here. So first off, we got the first numbers from Nvidia on H100. Now this is exciting. H100 is up to 6.5 times faster than the original A100 was when they initially submitted it. And the reason that it's fair to compare it to the original A100 and not this tuned 2.5 times faster A100 result is because the H100 is still in preview only. So this is not an official result. This is a preview result. But the preview of H100 looks really good in many use cases. And that's good for NVIDIA, and it's good for for all those users of NVIDIA, because frankly, NVIDIA is really dominating the high-end ML training world with H100. And a lot of supercomputers are using it. A lot of HPC systems are going to be using it. And we're really excited to see where that goes. So basically, they're dominating the buzz. That's kind of what I mean. But A100 is still here, and A100 still looks good. And as I said, A100 just keeps getting better. Now let's turn to Intel. Intel made news here with these results as well, because they're finally showing Gaudi 2 workloads. And frankly, Gaudi 2 looks really good. So again, this is Habana Labs, which is a company that Intel bought. Gaudi 2 is their training chip. And it looks great. In fact, Gaudi 2 is faster than A100 in BERT training and is even getting close to the initial H100 previews in ResNet 50 training. This is important because it shows that Intel has a competitive offering in some of the most valuable areas of machine learning. Now, this doesn't mean that NVIDIA is done for or something, no, by any stretch. What it means is that this is not a one-horse race. This is a many-horse race, and Gaudi 2 looks pretty good. So we're pretty excited about that. We saw a preview of Gaudi 2 at AI Field Day, and it looked great. And so it's nice to see that. The other thing Intel's doing here, though, is that they also did a preview. They did a preview of Sapphire Rapids. And you might be saying, wait, what? Sapphire Rapids is a CPU, not a GPU or an ML chip. And yet, Intel is using Sapphire Rapids for training, not just for inferencing. Sapphire Rapids for training, and it actually is not terrible. So the idea here is that maybe you don't want to buy specialized hardware if you can get by with just using a CPU. And so Intel is basically demoing a pretty straightforward two-processor Sapphire Rapids system with a pretty normal configuration. Of course, this is all pre-release stuff, but pretty normal configuration, the kind of stuff that you might buy in enterprise. And they're showing that they can do DLRM training in under an hour on that pretty simple basic server. And if that's good enough for you, then basically you don't need to buy specialized hardware, and that's a win for some customers in some use cases. They're also showing that if you have maybe an 8-node cluster of those dual processor systems, you could do BERT in under an hour, which again, if that's your goal, that would be great. You can even do ResNet 50. If you've got 16 nodes, you could do ResNet 50 in under 90 minutes, which again, that's a pretty heavy training situation. And if 90 minutes is good enough for you as a part-time training platform, then that's kind of not a bad deal considering the cost of a lot of these specialized processors.
Stephen, that was a great overview of the training part of it. But what about ML Tiny? What about the inferencing stuff? Because I think that there was something there too as well.
Oh yeah, and that's actually maybe even more exciting. I've been watching the other end of the MLPerf results myself because frankly, most of the time when it comes to ML, you're not training, you're inferencing, you're just using this stuff. And there's a lot of exciting things going on with low powered, low end, tiny devices. And that's what the tiny results are all about. So we saw some great results from companies like OctoML, Plumer AI, ST, Microelectronics, all using ARM Cortex processors. And frankly, they're not exciting compared to what you might get at high end ML, even inferencing chips. But it's interesting. It's exciting to show that the ARM Cortex processors can actually do ML inferencing on low power. And speaking of low power, I really have to call out Silicon Labs and Greenwaves. They showed accelerated, tiny, low-powered chips that were just incredible. Really low latency running these inferencing tasks. Greenwaves in particular, they're showing accelerator based on the RISC-V architecture, which is an exciting world, different from ARM, basically open licensing, and they're showing that they can do ML inferencing on a very useful scale to do useful tasks at very low power levels. And I'm going to be really excited to see where that goes as well, because again, this is kind of where it gets useful instead of sort of just the let's build a giant network of really expensive things and see how fast it can go.
Yeah, exactly. I think that that's something that we're definitely going to be covering on the rundown in the future, because there's a lot of great innovation that's being done in that space.